modes. So it says these are interesting propagation modes. They're ones that you never heard of, probably. Trans-equatorial, long path, gray line, which is the question that we think is removed, but just to be sure, I left it in.
Why is it being removed?
I don't know. I can't find anything saying it really was, but it's not in Dan's book. And apparently it's not on the ARL question.
Yeah, the ARL, let's see if I can find it.
But
again.
the question pool doesn't show it's removed. So
Oh,
it's just one question, simple one. So.
yeah.
Ordinary and extraordinary waves, which I had never heard of. Apparently that's more of an optical phenomenon, but then those are also electromagnetic waves, so it behaves the same. Chordal hop, which we'll talk to Greg about, and sporadic E. So trans-equatorial just means that you're communicating across the equator to 2 points that are mid-latitude. Basically the same distance north and south of the equator. And it can be up to 5,000 miles.
About halfway down the page right there, E3B8. It says it's removed from the question pool.
Okay.
It's still showing, I mean,
The question pool still has it, and there's no errata says it's not. So. Okay. So the best time is afternoon or early evening. Anybody here done a trans-equatorial?
I don't know.
We can't because we're just about on the equator. You couldn't go very far.
It says 5,000.
Huh?
It says 5,000.
Yeah, but
Yes.
equally,
25,
2,500, 2,500.
Right, but what I'm saying is, how far up is Florida? Because I've been on 6
Well,
meters.
we're
and
much more than 2,500.
on 6 meters, I did.
The equator's down in Ecuador. How far is Ecuador from here?
Oh, I don't know.
On 6 meters, I
Okay.
did Uruguay and Argentina this week on 6 meters, 4,700 miles. So I was up in Florida and they were in
Huh? All right.
Ecuador. I don't know if it's trans-equatorial.
Well, yeah. How do you know if you make a contact? How do you know how you're making the contact?
Well, it's got to be sporadic E, and
Yeah.
it's got to be double hop.
Okay.
But I don't know if you're going to call it trans-equatorial. That's a fancy name of it went over the equator.
Right. And it's a test question. It doesn't matter. So what is trans-equatorial propagation? Everybody go with alpha?
Yes.
Definitely.
No, we're way too far away.
Oh, really?
So we're more than 2,500.
I wouldn't have thought that.
Yeah, I think it,
So is Uruguay about the same distance south of the equator as we are north of the equator? I would say
Which country?
Uruguay.
Uruguay is on the equator.
No, it's not. Ecuador is.
I'm sorry, Ecuador.
Uruguay is what quite a bit south.
Yeah. Okay, what's the approximate range using trans-equatorial propagation?
I thought.
What's the best time of day?
This was like 5 o'clock.
Okay. Well, we're getting blocked there. Long path. It's a type of propagation where the longest of the two direct paths actually has better propagation than the short path. So for any 2 points, one path to it is longer than the other one, and sometimes that, called the long path, has a better propagation or less loss. Normally this is in the low, well, the lower HF, 160 to 10 meters. Well, that's all of HF, isn't it?
Yeah.
20 meters is the most frequent, from my limited experience, 20 meters seems to be the best for everything. Any time of day, anywhere. Which of the following amateur bands most frequently provides long path propagation?
Sounds like a favorite.
20 meters.
Bravo.
20 meters. Which amateur bands typically support long path propagation?
60 to 10, you say.
Yeah, they threw that other one in there to confuse you, 160 to 40.
Yeah,
Well, yeah, but 20's below that. We already established that 20's the best frequency.
Okay, I think this is sporadic E.
Yeah.
Maybe I have to move this down.
So we're a little less than 3,150 miles from the equator at this point here in Merritt Island, so.
We're that far.
Yeah,
Wow.
31.
how far? 3147 for this latitude.
And then if you looked at equidistant, I bet you Ecuador and Uruguay are about. They're gonna be a little more than.
Okay, sporadic E occurs when you have patches of ionization in the E layer. It's another E layer phenomenon. Can occur anytime and most likely around the summer solstice. So I guess it has to do with the density of oxygen atoms and whatever else gets ionized and how much radiation is actually getting through from the upper layer. So what time of day can sporadic E propagation occur? Anytime. At what time of year is sporadic E propagation most likely to occur?
The solstice is.
Alpha. But I guess it would be opposite on the northern hemisphere and the southern hemisphere then. Because the seasons are flipped.
Right. It's gotta be,
Yeah. Because the angle of the earth.
but,
Okay.
yeah,
What? Well, there's a lot of strange stuff happens at the poles. There's more absorption for some reason. I don't know if that's because of the angle
the
coming
solstice,
through or what.
the solstice is gonna be when the sun's most direct, right?
It's
Solstice
the longest
is,
day of the year. It's when we get the most sun, so it's the most.
right.
It's the angle.
So it's
with-
either closest to the pole or farthest away, depending which pole.
Mm.
The northern,
And then we tilt like this.
the northern, in our summer, we're farthest from the sun.
No.
No.
Summer,
Yeah.
we're further away.
Yeah, we're further away, but.
We're further away.
But
than
we're
the
tilted
angle of
more
the
in
earth
summer.
because of the
The tilt,
rotation of
the tilt is always the same. It's 22
3.5.
Okay.
degrees or something
Okay.
like that. But we have an elliptical orbit around the sun.
But the
and-
apparent tilt changes as it rotates.
Right.
Because this, it goes around, it gets close,
Okay,
but distance from the sun changes on a yearly basis.
right.
And during the summer, we happen to be the furthest away.
Because it has an apogee and perigee also.
Yes.
Or we do.
Mhm.
Unless the sun is rotating around us like it used to be.
No, no, no.
Ancient times.
It's because the earth is flat.
Well, yeah,
That's right.
technically the earth is flat, so it should be the same distance,
Yeah.
right?
The earth cannot be flat because we'd all have fallen off already because the cats would have pushed us off.
Okay, portal hop.
Yeah.
This is for Greg.
That's why I don't have cats. Yeah.
Okay, this can happen when radio waves are refracted in the ionosphere. So you have kind of a ducting effect. And from what I understand, it's because under certain conditions, the refraction angle changes. So you wind up with a lower refraction than you normally do off of the F1 or F2 layer with a hop to the ground. So you get up there with a shallower angle and it bounces like a duct through the ionosphere and eventually, comes back down to Earth. So you could conceivably have one hop into that duct all the way around and one hop back all the way around the Earth. Theoretically.
Like a wave guide.
Yeah. And there's less loss because you're not hitting the Earth as many times, which absorbs part of the signal every time it hits it.
All right, that means you could talk to your neighbor down the street with a delay.
Yes.
Okay.
Or yourself.
Hey,
You can
that's
hear
it.
yourself.
I've
If you're
heard
feeling really
I've heard
lonely.
the reverb from my voice.
I talk to myself as it is.
I do it on the telephone, I hear reverb sometimes. I must be doing that.
Okay. And there's a example where we started up here, we did a couple hops, we got into the lower refraction, bouncing around and finally back down to where we started. So the long path in that case could be, probably is, well, the way they show it is probably about the same, but could be less loss.
Except for this, you probably use a directional antenna, like a Yagi or something, long path, right?
Well, not necessarily.
It helps, but.
Yeah, I mean, you have a stronger signal going that way, but even with a vertical, I mean, part of your signal could go that way.
What really gives it away is when it's hopping over a region of darkness.
Well, that's
And
one of the
and
things that affects it.
Right, and it's gotta be an accordion hop because it won't propagate over that darkness.
Well,
some
it changes
at
the
some
refraction
frequencies.
angle over
Right.
because the F1, F2 layer has collapsed, right? At
Mhm.
night, if I remember right.
Mhm.
So that has some effect on it too.
So if you use the gray line, you only go north and south on when you have vernal equinox,
Yeah.
that way you can go all the way around just in one layer, one skip,
Okay.
possibly.
Okay.
I mean,
What's the primary characteristic of chordal hop propagation?
Excessive ionosphere refraction without an intermediate reflection from the ground.
All right. Why is chordal hop propagation desirable?
Less lossy.
Yeah.
Not that you have any control over it. It happens, I guess. Less loss because less ground hops. Okay, these weird things, ordinary and extraordinary waves. When you send out a linearly polarized signal, whether it's vertical or horizontal, when it gets to the ionosphere, apparently it's split into two different waves with different characteristics. And I don't know a whole lot about them. I couldn't really find much other than this is more of an optical phenomenon, but it also affects radio waves. And from what I understand, the ordinary wave and the extraordinary wave have slightly different angles of refraction. The extraordinary wave is absorbed more by the F layer. I don't know why. But the bottom line is when they come back out after being refracted, they're both elliptically polarized. And I think back in the general or tech, there was things that talked about that where they refracted off the ionosphere and they're converted to elliptically polarized. Apparently that's the mechanism that causes that. And that's all I know about it. This was the only real thing I could find. But it's really mostly showing, well, where you have at a certain angle, you can have a reflected wave, but you can also have this ordinary and extraordinary that don't get reflected and are refracted. Assuming it's an anisotropic medium. Does that mean it's a constant medium or it's not a constant medium?
No idea whatsoever.
It's the anisotropic. I think that means it's not consistent or constant. Anyway, what happens to linearly polarized radio waves that split into ordinary and extraordinary waves in the ionosphere?
They become elliptically polarized.
Elliptically polarized. What is meant by the terms extraordinary and ordinary waves? Yeah, they threw A in there to confuse you.
Yes, they did.
Anisotropic is a physical property that has a different value when measured in different directions.
So it's not consistent, not linear. Why did they say nonlinear?
You said isotropic.
Because the word of the day calendar was open to anisotropic when they were writing the question.
Okay.
Works for me.
All right. Here's the question that may or may not be in the pool anymore.
Yeah.
The gray line, the band around the Earth separating daylight from dark, called the terminator. Arnold. It allows long path propagation between 2 points, which are along the gray line or the terminator. I don't know why. They seem it's very efficient. I guess because the D layer on the dark side of the terminator has collapsed, so you have less absorption.
That's what they say.
And they're saying on the sunset side, it hasn't come back up. So I don't know. The whole thing's a little fuzzy to me.
Doesn't that mean it just goes one direction or on the?
Well, I don't know that it's directional.
Whatever, it's in the way, or it's in the
Well, sure, it's
interface.
just a gray line, it's north-south.
Yeah, exactly. But no,
No, it's not.
it can be tilted too, remember?
Oh, yeah.
No, it's not.
But it's a circle. It's a great circle word.
Is that a straight line? North south? Looks east-west down there at the Arctic.
Okay. All right.
I stand corrected.
It's a circle.
That's why we came here to watch these pictures.
I guess
The
when we're
gray,
thinking about in
it
the
shouldn't
small
be the
world of
gray
the
line,
United
then. It
States.
should be the gray circle.
No, and I don't understand why it's only at the line. Because it would seem like on the dark side of the line, you don't have any, why is it less? I'm not sure I don't understand what's unique about being right along the line. But I don't have to know.
That's the gray line.
It's just,
That's probably why it would-
What is
it's
it, June
unstable propagation conditions.
First day of summer, first day of winter, it's straight up and down,
Okay,
right? All other times it's tilted or looks like that.
okay.
The
So
gray line's
It would
pretty
go north and
unstable.
south most of the time, but except around the further north, you get more east and west. You get.
But what I don't understand, why does that make it propagate better than another point off
I
of the
don't
line?
know if it's in the morning or night that it works best.
Okay,
It's just unstable. That layer, that area is lit unstable.
okay.
And you find it with different effects.
Well, there's
because
only
it's-
one question.
And it's not on the question.
It may or may not be on. We don't know for sure. Somebody's wrong.
The question's too gray.
Right.
That's it.
So what's the term for the long path opening? And they refer to it as long path.
Well, it said that in the description too. It said it makes the long path more viable.
Yeah. But I would think it would make the short path even more,
No, because
as long as 2 points are on the gray line.
Yeah,
Okay, so what's the answer?
The,
You need a gray line.
alright,
Okay,
wow. Like rocking here.
yeah, I told you it's probably